Beautiful. Thank you, Molly. So, hello, everyone, and thank you for having us. My name is Chris Fortes, and together with my colleagues Ying Hu and Cody McCormack, I'd like to welcome you all and kick off the presentation of our GLG Capstone project, whose subtitle is A Match Made in Machine Learning Heaven, linking every client request to the best expert. This is the outline of our presentation, which we plan to tag team on and cover over the next 10 or so minutes. I'll start by covering the business problem and our proposed machine learning solution. Then Cody will cover the data and model pieces, along with the demo and the results. Finally, Ying will wrap things up by covering the MLE stack we have under the hood and future work before we open it up for Q&A. Let's see if we can find some automation opportunity here. For those of you who are not familiar with GLG, their business enables high-value matchmaking. More specifically, it all starts with a client who submits to GLG a request for access to an expert on a specific topic they essentially need to get smart at quickly. From the client's perspective, and assuming all goes well, just a few days later, they end up having a meeting by phone, video, or in person with an expert on quite possibly exactly the topic they need knowledge on. From GLG's standpoint, however, the challenge becomes, how can we process hundreds of these clients' requests a day so they are matched not only quickly, but also accurately with the best expert available in GLG's 1 million freelance database? Well, let's find out. How about some automation to the rescue? Considering the client request or data input is essentially text, we immediately gravitated towards natural language processing, or NLP. To illustrate with an example, we imagined that a client could submit the following request. I need to know what David Guetta is up to these days, including what he may do next. And in case you have no idea who David Guetta is, see the tiny picture below. He's a very famous and successful DJ. With that as input, we decided to learn and pursue NLP models that can perform information retrieval. More specifically, we aspire to work on models that could, in this example, call out that David Guetta is probably a person, pinpoint topics the client request is likely related to, such as DJ, dance music, French as his nationality, Ibiza as a place where he often works, and finally, identify previous GLG client requests that could be deemed similar to this one. All of this with a single-minded goal of semi-automating the process of understanding what the request is about so that the best available GLG expert can be quickly and accurately identified in what we call a match made in machine learning heaven. With that, I'd like to pass it on to Cody for the data and model section. Cody?
Thank you very much, Chris. So ideally, what we would have wanted to do in this situation was to have a corpus of GLG's actual tickets that have been submitted, so we could better understand exactly what types of questions they get, what types of experts they want to connect them to, and how those tickets have been handled in the past. But we didn't have that, so in lieu of that, we thought it would be good to use a news data set. The news data set we ended up settling on was a Google News data set that somebody had put on Kaggle and already had the NERs notated, which is very easy for us to do training on. We thought this would make sense because it has a great diversity of words in there. As you can see, there are about 35,000 unique words and 48,000 sentences. So we were able to get a lot of data and have a lot of diversity in data that we would actually expect to more or less match the type of problem we'd have if we did have access to GLG's tickets. After looking at the data and thinking through exactly what GLG would need here, we thought a three-model approach would be best. So the first model is name entity recognition. In the example Chris gave earlier, this would pull out things like David Guetta. This will give the experts at GLG a very good idea of exactly what's being requested, so they know who to connect clients to for their conversations. Model 2 is topic modeling. In the example we gave earlier, that would be pulling out things like DJ and dance music, so the GLG could see exactly what buckets of experts made sense and who to connect to. And model 3 is sentence matching. The idea here is that we'd be able to see exactly what tickets in the past had been very similar to this, so the GLG staff could see how those tickets were handled, how they were routed, and very quickly understand what needs to be done. So they wouldn't have to waste a lot of time doing research or asking people to figure out how to handle things. They could just move very quickly. Now, to give a quick demo of what this actually looks like in production, we have this website. We will be sending out a link to this afterwards so that everyone can play with it and see exactly how it works. Homepage gives a quick brief rundown of the things I've already covered and talks about how the models work. We have a team page if you want to learn more about any of us, what we do in our day jobs, or what our kind of goals are. And in the try it out section, we'll give you an example of how it actually works. So to give a sort of best case scenario, because we did train this on a news corpus, we have this sentence: as midterms near, Biden faces a nation as polarized as ever. When you click Let's Connect You, you get this output, tells you exactly what your text is, what the named entities are. Biden, that's the only named entity we had in our example, so that's perfect. Possibly related topics. The most related topic is party, president, election, leader, exactly what we'd expect. And other similar requests, but they're really similar sentences in this example, are other things about Biden and his term in office. So this is exactly what we'd expect, and this will give GLG a very quick ability to see what exactly is being discussed, what types of experts make the most sense here, and what other requests have been used in the past that are very similar. And now to give a sentence that's performing a little less well, but in keeping with our theme, we have David Guetta as a DJ who sometimes performs for rich kids in Ibiza, Spain, or Ibiza, Spain, which is how those rich kids would actually pronounce it. The named entities work very well. David Guetta, Ibiza, Spain. Possibly related topics go a little bit haywire because we train on a corpus of news and not a corpus about dance music or things of that nature. And the similar requests that use transformers work very well. It points us towards other performers of a similar caliber to David Guetta. And in terms of what this actually looks like for a business case, of course, we'd have to have more information about exactly what GLG's current process is to know exactly what the lift here would be. But based on our research, we saw other companies who had gone from a more manual process that GLG currently employs to a more automated process that leverages machine learning solutions. We'd expect to see about 80% time savings. The business case, as far as we see it, is this allows GLG to get much more done with much less. They don't have to worry about training and hiring staff. They don't have to worry about staff stopping to do a lot of research or talk to other people to figure out how to handle things. They can scale much more quickly and much more effectively and focus more on their core mission, which is connecting experts to clients. Now I'm going to pass it over to my colleague Ying so she can talk about the MLE stack and future work before we go into the Q&A section.
Thanks, Cody. So this slide shows you the deployment of the web application. There are 3 nested frames on the slide. If you look at the innermost frame, it shows that the application is written using Python's framework Flask, and the machine learning model serves as the backend of the application. We then containerize the application and the environment required to run it using Docker. And finally, the web application Cody just showed us is deployed on an EC2 instance on AWS. In the future, the first thing we like to do is to improve the outcome of our topic model. One immediate approach is to use a more diverse data set to train our model. The current data set we're using doesn't really contain enough tests for a diverse range of topics. So it's really hard for the LDA model to learn the word distribution of some of the less represented topics. We believe training the model on well-balanced diverse data should improve the outcome. Another approach, which is very different from what we have done, is to use a semi-supervised learning technique to labeling the request. The basic idea here is we first hand label a few samples, and then we can propagate the label to nearby requests. And here we are thinking using sentence transformer again to produce the embeddings of the request, which has shown extraordinary performance from our Model 3 output. Another direction for future work is to expand the scope of our project. This includes building the expert recommendation system, which is the second half of the solution Chris showed us earlier. We also noticed GLG has offices in Europe, Asia, and the Middle East, so it makes sense to adapt our model to non-English language as well. So before we move to Q&A session, we want to really thank everyone for listening. And Chris is going to drop the link to the app in the chat so everyone can play with it. This is all we have for you today, and we hope you enjoyed it. Now we're ready for your questions. Thank you.